Oh, hello. I just was blowing up my basketball so I could practice some hoops. But did you know that whenever you blow up a basketball, there's pressure inside that builds up on the surface, on the inside, and that's what causes these air bubbles, which are not good. Like if you get too much, it would cause these air bubbles. And this was from before, but since I blew it up this time, it bounces perfect. And if it's too hard, that's when you want to know that you have to let air out. And if it's too soft, you want to blow it back up. And whenever you blow something up, this is kind of like a bike tire. Pretty much anything uses pressure. This is science. Pressure is a force exerted on a surface. There are many types of pressure. One type of pressure is fluid pressure, which is used in this lab. And it's also used in airplanes when you're taking off, as your ears pop. Because when your ears pop, then the fluids in your ears kind of move around and they kind of clog up your ear. It causes the pressure to change and make you hear differently. What you'll need is a pop can filled with 1 centimeter of water, a heat source, and a crushed, and then you'll come out with a crushed can. When you'll fill up the pop can with about 1 centimeter of water, and then after that you will be sure to grab a handle and use the heat gun to heat up the pop can. And after a few minutes, the pop can will get crushed and become dented. Now, parental guidance is required for this lab because there's heat involved. As I said, there are many types of pressure. Another type of pressure is air pressure. Air pressure is almost everywhere in the world. It's at sea level, mountains, in the ozone layer, in aircraft, in the edge of space, and where the air pressure changes. Where the air pressure changes, it's where the altitude is very important in the surface air pressure. Moving air currents and storms affect surface air pressure. That's how meteorologists use the surface air to predict storm changes, the weather. At sea level, a column of air more than 150 kilometers high and pressure is down on the Earth's surface. Surface pressure is measured at sea level is 101,300 PA. Mountain air pressure steadily decreases the higher you get the air pressure, about 50,000 PA. The ozone layer has one layer of ozone gas at an altitude of 20 to 50 kilometers shields the Earth against harmful UV radiation. Air pressure is less than 100 PA in the ozone layer. An aircraft reaches an altitude of 11 kilometers and the air pressure is only 25,000 PA. No one can go up there unless they're in a pressurized cabin like in an airplane. And then the edge of space is at 150 kilometers and it contains few gas particles, which causes the pressure to approach zero. Beyond 150 kilometers is space, which is where a hydrogen molecule only is every cubic centimeter. There is another force that is used almost everywhere. This force is called buoyant force. In this lab, it shows a great example of buoyant force. I have one more after this. And what you need is a tall drinking glass with room temp water just to fill up an eyedropper. One soda bottle with room temperature water almost filled to the top. And you might want to get a thin flat bottle also, which is like a dish soap bottle, because then you could have 2 ways to demonstrate. And then you want one eyedropper. To set this up, you want to gradually draw water into the eyedropper until it floats barely above the surface of the tall drinking glass. Next, you want to transfer the eyedropper to the soda bottle. Do not change the amount of water in the dropper. If you do that, then it might not work properly. Now, when you do this, put the cap on the bottle and then squeeze the bottle to make the diver sink, rise, or hover at any depth. As you can see, when it's not squeezed, it's just going to float down. As means there's no pressure on it, so that means nothing's stopping it, so it can just float down. But when it's squeezed and when there's pressure, it's going to float right up. This is buoyant force. Buoyant force is the upward force acting on an object in a fluid. If the weight is greater than buoyant force, the object will sink. If the weight is equal, the object will remain at sea level like a fish. And if it weighs less than the buoyant force, the object will rise. And now I have an example of Diet Coke and Coca-Cola. Now, as you see, as I place these in the water, there is a big difference. The Diet Coke rises to the top and the regular Coke just sinks right to the bottom. And now this is because of the amount of sugar and plus the buoyant force against the Diet Coke. The weight of the Diet Coke is less than the buoyant force, which causes this to rise. And then Coca-Cola, this was so hard, so strong, it weighed so much that it just had to sink because it weighed way more than the buoyant force, which caused it to sink. And now I believe one of these reasons would be the calories, because there's 140 in a can of Coke, and in the can of Diet Coke there's only 0. Plus there's a difference in sugar. There is no sugar whatsoever in a Diet Coke, and there's sugar in a Coke. And that's what can cause the big weight difference. Hello and welcome to Science Facts with me, of course. Today we will learn about Archimedes, the Greek mathematician. He discovered that buoyant force is when water exerts on an object, whether it may float or become submerged. This is equal to the weight or volume of water the object displaces. Come back next time to learn more about science! As you shake a can, pressure builds up on the whole surface. It has nowhere to go until you open it. And that happens. When you open it, the pressure has nowhere to go but out. You never know how far. That's some good Coca-Cola.
Everybody got time for science. Everybody got time, everybody got time, everybody got time for science. I went downstairs to give me a cold pop and dropped it in the sink. I noticed that the pressure on the can was starting to make it sink. Everybody got time for science. Everybody got time, everybody got time, everybody got time for science. The can was less than, so that's what made it sink. This is called buoyant force. Buoyant force. Everybody got time for science. Everybody got time, everybody got time, everybody got time for science. Everybody got time for science. Everybody got time, everybody got time, everybody got time for science. I went downstairs to give me a cold pop and dropped it in the sink. I noticed that the pressure on the can was starting to make it sink. Everybody got time for science. Everybody got time, everybody got time, everybody got time for science. The can was less than, so that's what made it sink. This is called buoyant force. Buoyant force. Everybody got time for science. Everybody got time, everybody got time, everybody got time for science.
Chris, I don't think I taped that.